Okay, good evening everyone and welcome to the 60th SoConnect Data session. My name is Martijn Keizer, data engineer at Sogeti, and I will be your host for tonight. This evening we will look into the subject of data volume management. We see a large increase in the amount of data that organizations capture. This growth is only expected to increase even further due to the low cost of storage and the many data-intensive applications that companies have. Even though we can store all this data, should a business just store any data simply because they can? In the end, it will only cost them a lot of money, but it also has a serious effect on our environment. Tonight, Erik Sekeres will provide a deep dive into the world of data volume management. Not only will he provide us with insights on the effect of storing large volumes of data, but on top of that, he will give clear guidance on how to challenge the idea that we should store all the data that we have. Furthermore, he will provide practical tips on how to start with data volume management. Finishing this evening, there will be, of course, time for a Q&A at the end of the session. So please make sure that when you have a question, write them down in the chat, in Teams chat, so that we can, we can answer it or try to answer it at the end of the evening, and make this an interactive session. So before we start, please mute your microphone. You can leave the webcam on if you want. And once again, use the chat option in Teams for your remarks during the session. This session will be recorded and the link will be made available for you after the session. That being said, have fun tonight, and Erik, the floor is yours.
Okay, thank you, Martijn. As Martijn said, we're going to talk about data volume management. First of all, I will set the stage a bit, so tell you where I come from. I've been working in the IT for just over 26 years now, mostly as a database administrator, but also as cloud architect and various other roles. And in all those years, data and especially data volume, storage volume, has been a great discussion. But recently in the last few years, data storage has become abundantly available. So there's no more discussion, can we store it? But tonight we are going to explore the idea of should we store it? So that's a bit of what we're going to do this evening. And for that, I will take you through 4 distinct points. First of all, let's set the stage with talking about what is data lifecycle, what data scale are we talking about, and then viewing it from different angles, going to some perspectives on that data storage. And well, the most important part for me is something about tips and techniques, how to deal with storage, how to deal with your data. And I'm very much excited to hear about your opinions and your questions that you might have. So it's not really a Q&A, it's a Q&D, so questions and discussion. So let's get started. Like I said, first we're going to talk a bit about data lifecycle. And for data lifecycles, you can have various IDs, various pictures. So I chose a very simple one. Somewhere, somehow, data gets created. And in the discovery phase of the data lifecycle, it's all about what data do I have, what data comes in, what data is created. So you need to know where it is and where you can find it. That is the discovery phase. Then you're going to profile your data. You can maintain your data. You will eventually, hopefully, archive your data and either destroy it or maybe put it in some other form in your process and discover it again. So, like I said, data discovery, what data do you have? And what I see nowadays is that a lot of companies don't even know what data they actually have. A lot of data is stored, a lot of data is retained, but it's no longer a question of can we store it, but can you find it again? So a lot of companies have data that they don't even know that they have, but they still take up storage space. Once you have discovered what data you have, you must be using some way of profiling your data. So what characteristics apply to my data? Is it just plain documents? Is it something in a database? And you might be surprised that some companies are even surprised that they have a certain database in a certain area. So that's all about how do I see my data? What is the characteristic of this data, and what do I need to do with it? If you don't know that, then it will be almost impossible to do the next stage, which is maintaining your data. How to handle the data that you have, how to progress with your data, and eventually you should either archive or remove your data, because you cannot store it endlessly. So this is very short on data lifecycle. But what I also want to explicitly mention is the scale of storage. And well, starting out with a bit, which is almost nothing, a byte, 8 bits, the kilobyte, the megabyte, the gigabyte. And that's where we come into the realm of personal use. So in the high gigabytes, everyone, each and every person has some data, some way or another. On your phone, well, most phones have tens or even hundreds of gigabytes available of data storage. But for personal use, what you see is that, well, normally you would store up to a terabyte or maybe a few terabytes, but that's where the next realm starts. And nowadays, databases, a common size for database is terabyte size to tens or hundreds of terabytes. So between personal use and common database size, there's only one step actually, from gigabyte to terabyte. Then we have the petabyte, and eventually the exabyte. And well, surprisingly enough, when I looked this up, because I don't know this by heart, but in 2011, the total word storage capacity was about 300 exabytes. So it's more than 10 years ago, but then we were in the exabyte range. So talking about building up a pyramid, the total word storage 300 exabyte. Next one up is zettabyte. And it's estimated, well, you could say guessed, that in 2025, we as a total population will have 200 zettabytes of total storage. And in case that wasn't enough, they also created the yottabyte, which is just one step higher. I think they defined the next two steps already, but there's no consensus yet, so I didn't mention it here. Because in only 2 years time we will be in the zettabyte range, so no need to have those two additionally here. Then you might have noticed we're talking about thousands instead of the 1024 range we normally have. I actually don't like this term, because I really like to say gigabyte or terabyte in place from instead of a GB byte and tebibyte, but that's kind of the official term here. But it does make sense to make that distinction, because in the end, if you're talking about 1 yobi byte, which is 1.21 yottabyte, and that means that you have a 20% difference in gigabytes and terabytes. It's not that big a difference, but in yobi bytes it saves you 20%. So having said that, this is just an overview of what kind of storage capacities are we talking about when we're talking about terabytes, petabytes, and exabytes. So then we come to data volume management itself, and I would like to have 3 different angles on that, which is the economic perspective, ecological perspective, and a sense-making perspective. Starting with economic perspective. Well, storage costs money, so more storage costs more money. That's easy to understand. And I've been working with Oracle Cloud a lot, so my example here comes from standard storage on Oracle Cloud, which cost only, well, $2.50 per gigabyte per month, which translates to $25.5 per terabyte per month. Well, that's not terribly much, right? And if you store it on archive storage, and we will come to the difference between any standard and archive storage later, but if you store it on archive storage, which is cheaper, it's about 10 times as cheap. So it only costs 2.6 per terabyte per month. But having 1 terabyte will cost you a few dollars a year. So that's not an awful lot. But if you translate this to 8 exabytes, which is 8,192 petabytes, that will be a bit more. And why do I choose the 8 exabytes? Well, if you request any shared storage, and that's on the Oracle Cloud, that's on Azure, I think it's on AWS as well. It's a very normal size to have your shared storage. So if you request one shared storage, you will get 8 exabyte worth of storage, or you get up to 8 exabyte. They don't expect you to fill it, I think, but you can add a few of those. So, but 8 exabyte would be normal storage. So this is what you would see on a Linux machine. If you have a file share server requested in the normal way, then you would have 8 exabytes mounted here on mount backup, for example. And this is a real world example here. So it says used 0, usage percent is 0%. But actually, when you go to that mount point and ask what amount of data is stored, there's 12 terabytes of data. But it's not an awful lot, but it's not 0. So having a discrepancy between those 8 exabytes that you can actually store and the 12 terabytes that you have stored, you see you've stored nothing. So you think everything's okay, but you still have 12 terabytes. So, but that's how I come to that 8 exabyte of data. So like I said, that's so many petabytes and that's so many gigabytes. So if you translate that into dollars per month, then those 8.5 trillion gigabytes would cost you $22.3 million per month. If you would happen to have that 8 exabyte full. So then all of a sudden those limited amounts of money and that unlimited amount of data storage will translate into a significant amount of money per month. So storing everything is not a good idea from an economic perspective. And we can do the same from the ecological perspective. Again, some drives, and it doesn't really matter if it's hard disk or solid state disk, and any drive that is operational will use up energy. So more storage will use up more energy. So I've looked it up, and the estimates vary, very wildly, I would say. So there's an average estimate of 5 kilowatt hours per year per gigabyte data. And that's assuming that the underlying hard disk is not fully utilized, but for some percentage. I found these references, so I just looked for the one that is a very low estimate, because the 5 kilowatt hours per year per gigabyte. Other estimates have 46 kilowatt hours per year per terabyte. So there's a significant difference there. So let's take that low estimate. Let's just assume that all that data isn't stored on disk that consume too much, or aren't running all that much data transfers, that sort of thing. And again, with the 8 exabytes, petabytes, gigabytes, that would boil down to 388 gigawatt hour per year. So again, if you have that 8 exabyte shared storage on whatever cloud you have, that would cost, in the lowest estimate I have, 388 gigawatt hours per year. And to put that in perspective, we talked about the 200 zettabyte as total world storage in 2025. That's 9.9 exawatt hour per year. So this is the estimate for 2025. That we're using almost 10 exawatt hours per year on storage alone. And that's not storage in the cloud alone, that's all the storage we have. And I will compare that to the annual usage of the annual consumption of power in the United States. I found this number, that's 4.1 exawatt hour in 2022. So that means that if we eventually reach that 200 zettabytes of storage, we would be using twice the yearly consumption of energy in the entire United States. Well, it's kind of scares me. that it takes up that much power. And again, this is all to put it in perspective. So the numbers may vary, but even if this is a factor 10, either too low or too high, it's still a staggering number. And having those numbers, so both from the economical perspective and from the ecological perspective, does it even make sense to store all your data? So what questions do you need to ask yourself? Well, data is, for example, usually stored redundantly, but how much redundancy do you actually need? You can have triple redundancy. For example, in the cloud, it's very normal to have triple redundancy because all data centers have availability zones, but you can also replicate it to another region having, I'm not even sure how you call it, but 6 times redundancy of your data. You should think about policies for keeping database backups, or for that matter, any data backup. Do you want to keep it for 1 month, 1 year, 10 years? If you don't think about it, it will be there forever. So does it make sense to have your data retention on 10 years, for example? And always, well, we calculated some things about those 8 exabytes. So cloud storage seems very cheap. For a few dollars a year, you can store your terabytes, but in the end, it really adds up. So we will take a look at that later during the rest of the presentation. But these are the kind of questions you will need to ask yourself when you have data stored. And then coming back to the title, the data minimalization. And yeah, I just want to make a short distinction between minimization and minimalization, because there is a difference. Because minimization is making something smaller, and minimalization is making less of something or making something less. Either way, those are 2 different ways of seeing the same data, or handling the data you have. But for the first one, you have more questions like, can you store the same information in a different format? Like you can store things in XML, in JSON, you could store them in CSV, you could store them in flat ASCII files. And for example, XML has a huge overhead on your data, and it's very descriptive, but it also takes up a lot of space. For that matter, any ASCII-based data, could you compress your data? So you have the same data content, you have the same information in your data, in whatever way it is, in your database, in a document, in whatever form, you can make it possibly smaller. And on the other hand, you should be thinking about not collecting all data, but only relevant data. That's minimalization. So you will actually have less data. But the relevant question is, do you need all that data? And this could come together in the term don't store data just because you can. And for example, GDPR, all those guidelines on what data you should or could have, those will help you with storing only the data that is relevant for the set that you're interested in, and only keep it for the time you need it. So basically, it's very simple. Don't store everything just because you can. And then let's go to some tips and techniques. I will give you some examples of what I've found in the last years, but well, this has been going on for quite a while. It's not that data storage has become very different, but the availability of storage is different now. It seems endless. So like with everything that seems endless, you can try and use it whenever and however you like. But how to keep it in check, and keep in mind the 3 perspectives we have. Is it very economical to do so? Is it sustainable? Is it ecologically responsible to do so? And last but not least, does it make sense? So the first thing I want to talk about is compression. Well, basically, compressed data saves space. So it saves cost and energy. Like we saw, if you have less data, then you need less drives, and you just use less energy, you use less money. compressing data should be done in a way that you still can have all the data back, obviously, because if you compress the data and uncompress it and you don't have the same information, then you're throwing something away that you shouldn't probably. So compressing data is a two-way process. You can compress it, you can uncompress it. But compressing itself does cost energy. Because it's a very CPU intensive task. So any compute node or machine or whatever is doing its best to compress all that data. And you can imagine that compressing a few megabytes of data doesn't take all that much time. But if you have tried to compress a 2 GB file on your laptop, for example, you can see it takes significantly more time. So let alone that you're trying to compress that 8 exabyte of data that we saw. So it's very CPU intensive. A lot of energy and that cost is involved in compressing itself. So my point here is compression is useful for storing older data, well, probably older data, that you use very infrequently or not at all. If you have data that you must have, compliancy wise, for audits, for whatever, but you don't intend to use all that much, or you have backups that you want to store, but you don't, well, you never intend to use that backup, because if you do you need a backup, it will be because a failure has happened and you need to restore older data. But compressing those backups will save you a lot of storage. Also keep in mind that when you need that data, it must be uncompressed. So very infrequently used or not at all, that's the ideal data that you can try to compress. And then let's talk about redundancy. Basic is make sure your data has sufficient redundancy. Well, not too little, not too much. Sounds easy enough, but what is sufficient redundancy? You can have hidden redundancy. When you have, yeah, I'm talking about the database because of my database background. But when your database is larger than necessary, a backup or a replicated database will also be larger than necessary. So redundancy can really add up here. For example, we have one customer with just a 1 terabyte database, but of that 1 terabyte assigned storage, I think there's 300 gigabytes of free space. So it's basically all zeros. But the storage has been assigned. So if you replicate that database, it's still 1 terabyte. It's not losing that 30% of overhead. It's just the same terabyte. If you create a backup of that database, if you compress it, it will be significantly smaller. But just a regular backup will also be 1 terabyte. So redundancy of that data is even when you have zeros in your data, it's still taking up that space. So what is sufficiently redundant? Sufficient is when you can shrink that database, or if you can compress that database, if you can get it back without doing any special activities, that would be sufficiently redundant. And this is just from a storage perspective, because if you have large data files with a huge amount of redundancy, copying, synchronizing, sifting through all the data, like querying or just recollecting and any documents from storage, that may also take longer than necessary. It will induce more network traffic. It will slow down the entire system. And redundancy, like I said, within the cloud is normally a 3-way redundancy. So your data is stored 3 times already. And just for like in Amsterdam, you have large data centers, triple redundancy. But well, let's say that Amsterdam data center, the region entirely fails. Then a lot of companies choose to have that data replicated to, for example, Germany or Belgium or France or whatever is nearest. because of the latency, of course. But then you will have your data 6 times. And well, for 1 terabyte, it's not all that bad. But imagine you have that 8 exabyte data somewhere, somehow, then you will have stored 48 exabytes of data instead of just the 8 that you think you have. So take care of not having too much redundancy. And about cleaning, one of my favorite topics, because it can be such a complex one, but it can also be so easy. Problems with filtering data from an active database with relational data, for example. How are you going to figure out what data can be deleted, what data needs to be kept? Just a very simple model. This is just 17 tables, but if you want to delete some data here, and in a relational model that could be a big problem, because there are all kinds of dependencies. All these tables are linked somehow. So if you want to, let's say, drop one person. So we're looking at the table in the middle here. We want to drop one person. On what criterion are we going to drop this person? Is that when the end date of his or her employment is passed for like 7 years? Is it when the last let's say products go out of stock that they might have ordered somewhere somehow? There are all kinds of dates, and this is just example for when you're using dates to purge your data. So how are you going to delete it? In what order are you going to delete it? Can you delete it? Should you delete it? Relational databases are very good in storing data, but they're terrible when you don't have a clue on where to start cleaning out your data. And this is just a relational database. Imagine that you have a database with all kinds of references to documents, and for simplicity, you stored your documents on a web server or a shared storage. Then there's no hard link between those documents and what you have in the database. Based on what are you going to clean up your documents? This is the main reason why databases can only grow, because no one has a clue on how to clean them up. And could be very simple if you define a retention policy, a cleanup policy from the start. So if you're creating a data model, if you're creating a new database, I would immediately define a cleanup policy, a retention policy. So make sure you know what to delete, when to delete it, how to delete it. If you know what to delete, well, then you understand your data model. You know where to start. You know how it all comes together. You know how to delete the tables, delete any accompanying documents on a web server, that sort of thing. That's what to delete. When to delete, well, that might get a bit simpler, because you can base it on a date or several dates. You can base it on all kinds of policies. How to delete it is then just a technical thing. But if you don't do this from the start and you allow a data model to grow, well, unchecked, to grow in the next few months or few years, you will get into trouble if you don't know how to delete it. So, like I said, this is a favorite of mine. Make sure you have a good cleaning policy for your data. Then about retention and versioning. For example, keeping backups ensures you can restore and recover, but how long do you need to keep backups? What I do see is normally for a production environment, you have like a 30-day retention, but even a 30-day retention can amount to several terabytes of backups. And why do you keep those backups? If it's a highly volatile production database, then how big is the chance that you can go back for 4 weeks? Because that's essentially what you're doing. If everything goes wrong, then you can restore up to 4 weeks, or you can look at your data from 4 weeks ago. And actually, that's not what you see in practice. What you see is, what was my data yesterday? What was my data an hour ago? Maybe what was my data last week? It's been almost never that I've heard a question about what was it 2 weeks ago, or even longer than that. So how long do you need to keep your backups? How long do you need that retention? Well, basically, I would say go for a week or two for production environment. And for acceptance or test or development environments, you could do it with very much shorter backups, like 2 days, a week, perhaps, all based on your needs, of course. But do keep in mind that keeping backups takes up storage, but it can also make it very much more complicated to retrieve the right backup, because you will be sifting through a lot of backup files, a lot of backup possibilities. Was this file from last week? Was it from 2 weeks ago? So how long do you need to keep your backups is a very valid question in this case. Same with log retention. In the last years, but well, I think it's been for the last decades, log files are being kept, and there are a lot of systems that can capture those log files. Splunk is one of the favorites here. So you can store the contents of those logs, you can keep track of what goes on in those logs, but what people do forget, well, what I do see a lot, is that the log files on the server can grow unchecked. And it has been quite a few times that I want to check a log file on a new system. I try to see what kind of errors do you see, what kind of warnings do you see, and then they come up with a 2 GB log file. Well, if you try to open that on a Linux machine, it's well, sometimes impossible. Yeah, depending on the amount of memory you have on that machine, it might work. But sifting through a 2 GB log file is nonsense in my opinion. So not only how long do you need to keep those logs, but also add some log rotation. Don't let them grow too big. You cannot sift through that data whenever there's an error. You will be always looking at log files that are way too large. Keep them in check, keep them small. And if you really want to retain the data that's in the logs, use a tool for that, like Splunk, to put the data there. It's organized, and even then, we go back to retention. How long do you want to keep those logs? How important is it to have the logs from last year or 2 years back? Also, whenever you set up such a tool, it has a database, it has a repository, it has anything to store those logs. Immediately define that retention policy for those logs. And there's a slightly different thing, which is versioning. And I was mainly thinking about that because when I was creating this presentation, I stored it in OneDrive. Well, that's what most people do. So if you go back to previous states in OneDrive, that also means that it's not only the size of this presentation that is being kept, it's also the change log that is being kept. And I'm not sure how large that will be, but I don't need to go back to the presentation state of 2 weeks back. In the meanwhile, I've done a lot on this presentation, so I don't need the state of 2 weeks ago. So do you need infinite versions of your data? Well, most cloud providers, for example, assume you do. If you have some kind of bucket, some kind of bucket storage, then if you enable versioning, then it will retain all those older versions if you don't explicitly set a versioning policy. Versioning policy might be, well, only keep the last X versions or keep them for X amount of time. But if you don't do that, any update to the document will be retained somehow, somewhere. So make sure you have a versioning policy in place, especially when you're going to cloud solutions. But OneDrive at that is just another cloud solution. But in this case, it did help me once because I threw away a slide just after I made some modifications and I couldn't remember what the modifications were. So I was happy enough to use a previous state. But like I said, I'm not going back to the state it was in last week. I only need a few minutes most of the time. And then the storage tiers. Remember at the beginning where I spoke about normal storage or standard storage and archive storage. Well, for storage tiers, what we call hot storage is immediately available and it's fast. That's the storage you want to use for normal day-to-day usage. This is where you store your current data, so to speak. Then inevitably you would have cold storage, which is available with some delay, or it's slower, or both. And cold storage is mainly for all that data that you want to have somewhere or somehow, but you don't need it every day. Could be that you're storing your backups, for example, on cold storage, and your actual database or your actual data and documents on the hot storage. Cold storage is still always accessible, but it might be slower. It might be with some delay, so it takes you a bit longer to download your file, to access your data, that sort of thing. And then what I called archive storage, it's also called glacier storage, I think, in Amazon. There are all kinds of terms for it, but it's kind of offline and only available after request. So what you would have when you store something, or used to store something on tape drives, and then just put the tape somewhere in a cabinet, and that's it. So it's offline, but it's still available after request. And when would you use that? Well, obviously, if you have to retain your data for a longer time, but you don't need frequent access, or you don't need access at all, but it's just because of a policy. And in that sense, archive storage is a good solution, because even if the drives are containing that storage are unmounted or whatever, they don't use up any electricity or whatever. So the footprint, at least the ecological footprint of those kind of storage, is much better. Before I go to the insights, because we at Sogeti have sustainability as very important, but with all that I've said so far, the examples that I gave, it's all about knowing where your data is, what data do you have, and how to handle your data. And going to these tools, I will have two examples of tools. I'm going to give some idea of how you could handle that. And the first thing is a carbon estimator. It's an app powered by AI, and in this case, it displays to you what CO2 emission is being produced by, for example, here storage or memory or compute nodes. So this app aggregates all kinds of data from, in this case, Google Cloud, AWS, Azure, could be Oracle Cloud, could be any cloud or on-premises environment that you have. And it aggregates all the data, and it does an estimation of you use this much storage or this much compute power. So this is the carbon footprint that you have. And yeah, what I like obviously about this is that hard disk and solid state disk storage are prominently here. So if you have a lot of storage, you could say reducing that storage and reducing the usage of that storage will also reduce my total footprint. And this is a very nice part of the app, where it says if you would like to offset your carbon emissions, then you have to plant 33 trees. And I'm not sure if that's per year or per month, but I think it's configurable. So, but this gives you a very good insight in where is the money going, where is the electricity going. So what is my carbon footprint? How much do I spend and how much do I pollute, essentially? Cloud economics dashboard, and this is basically just the raw data. So this is not the actual dashboard, but the raw data for a cloud economic dashboard does kind of the same. It goes over over various axes, and it says how to see your cost divided by business lines, but more importantly for this, for services. And this is about a data warehouse environment. Storage is, I'm not sure if that's, I think it's terabytes. I'm not totally sure because of the cost here, but reserved instance cost here. So the total cost is $43,000 per month on storage alone. Yeah, and I like this part, of course, because storage is at the top, and we're talking about data volumes here. So this gives you insight in where does the money go. So combined with that carbon emission footprint app that we have various ways of getting more insights into what we're actually doing on the cloud or on premises. And this is a good starting point for where do you want to go with your data. So, and I see that I talk a lot faster than I had expected. So we are nearing the end of the presentation here. So talking about data footprint, are you aware of your personal data footprint? I hope that I've given you some insights in what is your personal data footprint? How can you discover your data? How can you profile your data? And possibly how can you clean your data? But more importantly, are you aware of the data footprint of your company or your client? Because that's a lot more data than in your personal use. And my final question to you would be, what are you going to do to minimize that footprint? How we're going to have our data volumes sustainable? How we're keeping them manageable? What are you going to do? And with that, I would like to open the questions and discussion.
Yes, thank you very much, Erik. Really love the presentation. I think it's very actual. And so if anyone has a question, please feel free to either type it in chat or unmute your mic or raise your hand, and we will answer your question. But just to start off, I have a question myself. You mentioned a lot of different tips and techniques how you can minimize your data footprint. If I go to work tomorrow, what should you suggest that would be the first step to implement into the company? What would be the easiest win, so to say, to make some progress over there?
Depends on what area you're working in. If you're working with databases, then definitely looking at database retention times. It's not an easy win, but it's a big win, especially with relational databases. Is there any cleanup policy? But also with non-relational and especially document databases, they can grow very fast. If you don't have that retention policy in order, that cleaning policy in order. Looking at server size, well, then you could go back to for example, the operating system, if you do have access to it, and just take a quick look at how the drives are distributed. Are there any drives that draw your attention, like those 8 exabyte shared drives? What is actually on there? Do we need it? That's the main question you should be asking yourself. If you look at any environment tomorrow, if you go back to work, but you could do it at home as well. Look at any device and see what kind of data it is storing. Discover your data. That's basically the first step.
Okay, thanks. To follow up on that, I think there's a lot indeed to gain in this area. Do you think that this should be a skill that is embedded in, well, all of our working with data, or should there be someone responsible for data volume management as a separate role, for example? What do you think on that?
I think it could be a separate role, but I would expect it to fall somewhere under the infrastructure. If any company or any department is requesting data again and again and again, it's easy just to add that data, but someone should be asking the questions, why do you need the data? Have you looked at your current data? Did you try to clean it up? What are you doing with the data? What are your intentions? Do you need this every month? Because if someone is requesting another terabyte of data, well, it's not a terrible lot, but if they request 1 terabyte every month, then someone should wake up and say, well, can't you delete older data to free up that same space? Yeah. So I think it's in the infra department, to be honest.
Okay, cool. I see a lot of hands. I think Jelle was the first one. So I don't hear you, Jelle. I see that you're on mute, but
maybe you can type your question in the or your remark in the chat.
You hear me now?
Yeah, yes, now we can hear you.
I have one question, Erik. If we are going to delete data from tables in a database, the size of the database will not shrink.
That's right. Well, for most databases, that is true. I've been working with Oracle database, and then there it's definitely true. If you have a 1 terabyte database and you clean out 500 gigabytes of data from that database, it will still be a 1 terabyte database.
Yeah.
So what I've done recently for one of the customers is clean out a lot of data, but they're filling it up at, I won't say almost the same rate, but they're filling up the same space. If you're deleting data from 10 years ago in, for example, the customers or the orders table or whatever table you have, it's most likely that you will be filling those same tables. So you could see it as reserved space. And if you keep those in balance, so delete just as many records as you insert, then the database is at least at a stable size instead of adding 100 gigabytes every month, which it would boil down to if we didn't clean it up.
Yeah, because I work with the ING, and the bank records needs to keep their data for 7 years. And the databases keep the same size all the time. It's not 10 gigabytes, no, it's 60 terabytes at ING. And it's always the same question. What do we do with all this data? You know, we can go through a tape or something, but the data files of the database will keep the same size.
Yeah, but like with the previous example, if that's the amount of data you need, then it's not too bad, because then a cleaning policy could make sure that it doesn't grow even further, because otherwise in 2 years time you would have a 70 terabyte, into another 2 years time you have an 80 terabyte database. What you mentioned is also a very good point, that they retain it for 7 years. We do have a company, we do have a customer that has a retention of database backups, yearly backups for 10 years. What we did see is they have 10 years worth of backup, but again, that's an Oracle database. But every 3 years, you have a major upgrade of the RDBMS software. So you have database backups from 10 years ago, which is then still Oracle 9 or something like that. So you do have the backup, so you're compliant with the policy, but do you have the software? Do you have the 9i software? Do you have hardware to run it on? Can you restore that backup? Because it's 3 versions behind of where you are now.
There's a policy of reorganize the database, put back the backups, you know, so you can get your space back. But it's not always available, the time in the week or in the, you know, it's a lot of work to do.
Yeah, and you should definitely have that kind of process automated if you're going to do that at all, because with a 60 terabyte database, well, it will take, well, probably much longer than just a day or a week to shrink the database. And that's why I say have a cleaning policy defined upfront, so you won't get in that situation.
Yeah, I understand. And what I say at ING is, okay, buy some storage, please, now.
Yeah, but that basically that's the easy way out, and that's
Yeah.
what I'm trying to prove with this presentation. You shouldn't go there. Not just adding
No.
storage because you can.
No, and I disagree with that. You know, I disagree with slow running queries. Get it done, and don't buy any hardware or something. You know. Yeah, I'm sorry, but this is the discussion we had in the ING all the time, and they say, okay,
It's a very common discussion, I think. Yeah.
Yeah. Okay. Thank you, Eric. Thank you.
Thank you for your input.
Yeah. I also see that Dennis has raised his hand.
Yeah, that's right.
Yeah,
I liked your idea about the retention policy, Eric. I think that's a good one to implement if there is no retention policy yet. I am wondering if this is so important if it's so important to reduce your carbon footprint. Is it something like an innovation that's being picked up in the market as well? So are there vendors who are developing maybe solutions for that, so that you don't only monitor, because that's the tools that you showed earlier, but also advise or maybe help to reduce the amount of data that needs to be saved?
I do think that with GDPR, a lot of software vendors or a lot of application vendors, application developers, are aware that you need to implement retention times, cleaning policies, that sort of thing, because now you are obligated to delete that data. So I think that was a boost for defining retention and cleaning. But overall, within companies, it's a very tricky thing, because you most of the time have legacy systems. And like I said, if you have, well, let's take the example that Jelle mentioned. If you have 60 terabytes of data, it will not be easy to define a cleaning policy. Where do you start? Where do you end? What do you do with that retention? But specifically for new systems and for new software, I think a lot of vendors and a lot of distributors take that into account more and more, if only for GDPR.
Yeah, but it still is, the solution is still in the process and in the policies and not in the technique. At least that's what I'm hearing from you.
Yeah. Okay. Yeah, and when you have a custom data model, you also have a custom cleaning policy. So if you're using an out-of-the-box ERP or HR system or whatever, you hope that the vendor has implemented such as a cleaning or retention policy.
Yeah.
But I don't think that's very often the case.
Okay.
I always hope so, but I know better.
Maybe it's something to promote when we go out to our customers, that we have our retention policy with us. So we take that into account. Okay.
Well,
thanks.
I think that's item 1 on the list. If someone would request you to add storage, the first thing you should do is ask them why.
Yeah, exactly. Yeah.
It's very simple.
Good question. Yeah. Nice. Thanks.
And
thank you for your input. Yeah, go ahead. Yeah.
Companies are scared to delete data.
Absolutely.
Yeah. I witnessed that at ING. Hey, get lost of all this data. Terabytes. No. You know. Yeah. I ask questions. Why not? It costs a lot of money, all your storage, but they don't dare. They don't want to do it. But okay.
I think that has that everything to do with your deletion and cleaning up retention policies. If you don't know what you're actually deleting, and if you're allowed to delete it, like in the simple data model I showed, those were only 17 tables. And if you don't know where to start, you don't know where it will end. And if you start deleting data, then you don't know if any other links might break. Well, they will not break, but an application might have a terrible time if you just order the delete the order lines instead of the entire order. Just a simple example, but and that's why companies nowadays and well in the last decades I would say are afraid to delete data.
Yeah.
And I can relate to that. I do make backups of all my drives on all the laptops, on all the devices. But I'm hesitant to delete even the ones from 5 years ago. No, who knows what might be in there? But it's ridiculous.
Yeah, but
if I haven't touched it for 5 years, then I probably won't touch it in the next 5 years.
I told the guys, put it to tape. No problem. You know, but okay.
Yeah, but then, okay, so take that into consideration. You put it to tape, but how often do you test if that tape is still readable?
Yeah,
because tapes can degrade. And it's just like with those database backups from 9 years ago, from 3 versions back. Can you restore it? So there should also be a cycle to test if the backup you created is actually usable.
You're right, Erik. You're right. Yeah.
Okay, thanks again for the input.
I think we also have another question. I see a hand raised again. Feel free to ask your question if you have a question.
Is it me with the raised hand?
Yeah,
it was you, yes.
For Jelle, I can say, well, I will say I work for same company as Capgemini Sogeti as an information management consultant. And if I go to a client, and I agree with Erik, I am the queen of deletion. I call it Cinderella of IT.
Okay.
It's not the question, why are you afraid of deleting? I turn it around. I have my risk and compliance schedule, and I tell my client, it's not if you want to delete, but the law is telling you you have to delete.
Yeah.
And every company has its own laws they have to fill up to. And especially when we look at sustainability with the new law, European law that is coming with the CSRD, you can push people even more to say, hey, this new law is coming, so you are obliged to delete this and this and this data.
Oh, wow.
So that's what I always do. They always ask us to, can you clean up something because we don't see it anymore? And then I have to say, and that's what is Erik telling too, I always have to teach them a little bit. Okay, I can clean it up, but do you want me to come back over 1 year? Or should we put in some policies and procedures in place and look at the law and to say, okay, this is what I have to do. It's not if you want to, but you have to.
Okay.
And usually that's really a convincing story to tell people, hey, you don't have any option anymore. You must.
Wow.
So maybe that will help you.
But I can...
First of all, Solange, I think you've got the coolest job title ever. I think Cinderella of Data is something that everybody would like to have on LinkedIn profile.
My God. But I'm not obliged to have the law in my... I cannot tell the ING van you have to do this and you have to do that.
Yes, you have, because I'm working with ING too, but I'm working with them in Belgium. And I worked with a little company within ING, and the banks, they have their laws. And with the last one, I cleaned up, but it's a small company. But eventually, of the 10 terabytes they had, we cleaned out 6 terabytes. Only on law, not only GDPR, but all the laws a bank has to apply to.
Okay. Thank you very much. Thank you very much.
So look at the retention, what Erik is saying. Look at the retentions they have to comply to. and you can clean up
okay.
a lot of stuff. Yeah.
Yeah.
And
But
remember what we started with, the data lifecycle, discover.
Yes.
Sometimes you don't even know the data is there. And it's on some obscure storage. It's somewhere you don't expect it. If you don't know that the data is there, yeah, well, then you can't do anything.
Then I can give, that's one of the best quick wins you can have within companies if you have clients. I do a lot of Microsoft 365 projects now, because with COVID, everybody started to put a lot of things online. And the first quick win what you have with the client when you go in, just ask them how many SharePoints and how many Teams do you have? First, mostly they don't know. And if I let them look at it, you will see I did a bank in Paris. They had 300,000 different SharePoints.
man.
So, and then it's the question again of the life cycle. Yeah, but when was it used for the last time? Yeah, nobody used it the last 2 or 3 years because at one point COVID was over. So it can all be deleted.
Wow. Thank you very much.
You're welcome.
Do we have any other questions? Otherwise, I have still one question left. Because we see indeed that the amount of storage will, well, drastically increase, but at the same time, I guess, if you look back at the history, the cost of storage also decreases over time. So will that slow down the incentive to delete this kind of data? Because perhaps storing a lot more data in the end will be just as expensive as it is now?
Looking from incentive perspective, yeah, I think that will definitely slow it down, because storage used to be very expensive. Like we talked about before the presentation, 30 years ago, you would have a few megabytes, few gigabytes drive, and you were very happy with that. But it did cost quite some money. Now you have 4 terabytes fastest SSD for home use for just a few dollars, so to speak. Well, okay, not a few, but you know where I'm going with that.
Yeah.
If storage becomes cheaper and cheaper, the incentive to use less storage is going down, but environmental awareness is going up, and it's going up fast. So not only should you have a driver of reducing cost, but especially reducing your carbon footprint. And I think that with the green movement that we have going today, that's a very strong incentive for a lot of companies.
Yeah, I agree. I think the focus indeed will probably shift from economic to more environmental to reduce your data indeed.
Yeah. And if that doesn't help, you always have the sense-making argument. Why, for goodness sake, do you need that data?
Yeah.
Okay, thank you for your question.
Yeah. I don't see anyone with any questions, I think. So if that is...
Can I make a remark?
Definitely.
Of course you can.
Because I was curious to see, hey, how are other people thinking about the subject? And it's really nice, Eric, to see in your story that we all have the same view for the future, that we have to tell people it's time to start deleting your data because it's out of control. So it's nice to see different companies have the same vision to say, hey guys, we can help you, but it's time for you to come into action. So very nice presentation.
Thank you very much. And then I would like to ask the rest of the audience, and this is always a bit of a tricky point, of course, but like I put in the, let's go back one slide. Is there anyone who wants to comment on this last one? What are you going to do? What is the next thing you're going to do? What do you take out of this presentation? Just let's say 1, 2, 3 people who can comment on that.
the retention policy. I will take that with me under my arm to my assignment. Yeah.
Very good.
Yeah, I think as well I will take your tips to my client, but I'm also very curious indeed to look at my personal data on my mobile phone. I have a lot of photos that are being sent through that you see, and then it's saved on your mobile. So that's also like a small thing that you can do, and I actually will do probably tonight or tomorrow to look. Okay, what can I delete over there? I think it's a good mindset to have and then take it with you wherever you go. Yeah.
Great. Anyone else care to comment? If not, then thank you for your inputs. Thank you for your attention, and I will give the stage back to Martijn.
Yes. Once again, thank you, Erik, very much for your presentation. And let's move on to the SoConnect Data Outlook. Our next session is actually already planned for next week on the 21st of September. During this session, we will continue with our journey of data mesh. To be more specific, our expert panel will discuss about everything related to the self-serve data platform. So make sure to join that one. And on top of that, we also have another session on the 5th of October, and we will have our quarterly Power BI feature update. And during this session, we will walk you through the latest and most important features that have been released in the last quarter. In other words, a session that you must join if you are interested in anything related to Power BI. For the entire planning of the SoConnect data sessions, please check out our SoConnect meetup page where all the events are being posted. And they are open for everyone, so feel free to invite others as well. Furthermore, we also share our thoughts on data and AI-related technology and approaches on Medium. So have a look at that as well, and all the links will be posted in the chat. Let me post them actually as we speak, so you can browse over there. Yeah, here they are. And lastly, I think great in line with the data volume management, we are proud to share that Sogeti is hosting a sustainability week. During this week, which is hosted by Young Sogeti, there will be all kinds of activities to have a positive impact on your environment. So, for example, we have a green innovation challenge where you can where we challenge you to pitch your green initiatives, and also we have the community cleanup where we'll go outside and collect as much litter as possible. And by joining these activities, you will not only have a direct impact on your environment and meet a lot of new people that are also eager to do something good, but based on our collective efforts, we will also plant some new Sogeti trees. So make sure to either join by scanning the QR code, or if you're from outside Sogeti, please send me a message and we'll make sure that you can join this week as well. Lastly, I would like to thank Erik once again for sharing his experience, knowledge, and best practices on the topic of data volume management with us tonight. And of course, thank you all for joining. I'm looking forward to see you again next week or in one of the following SoConnect data sessions. Have a great evening and hope to see you soon. Thank you.
Okie dokie, dank je.
Thank you, everyone.
Thank you.
Have a nice evening.
Bye.
Bye bye.